Hello, good afternoon students. Welcome to Infinity Learn by Sri Chaitanya. This is Suresh, Faculty of Chemistry. Welcome to this YouTube channel by Infinity Learn by Sri Chaitanya. So this Infinity Learn YouTube channel is especially meant for NCERT line by line NEET preparation. Welcome to the session. Today's class of interest is going to be hydrocarbons. It is the most impacting topic in the organic chemistry. This NCERT related hydrocarbons topic we are going to discuss in today: alkane, alkene and alkyne. So I just want to say something about this hydrocarbon. Dear students, if you are very good at hydrocarbons, you can command the total organic chemistry. So line by line we are going to say from the hydrocarbons, and let us start with alkanes. So what are you going to learn in today's class? The hydrocarbons we are going to see alkane, alkene and alkyne and cycloalkanes and arenes. In this scenario, we will start in journey. Hydrocarbons contain, the hydrocarbons are nothing but they contain only carbon and hydrogen species. There can be alkanes, only carbon to carbon single bond species are seen. Alkenes, carbon to carbon double bond species, and alkynes where the compounds contain carbon to carbon triple bonds. And aromatic hydrocarbons, they contain benzene and related kind of structural aspect. So they are said to be arenes. In this arenes you are going to see aromaticity, benzene and benzene related preparation properties, electrophilic, aromatic substitution and everything we are going to see. But so, and alkanes, we just say alkanes, as I said, it is all contain single bonds in the structural aspect. Their general formula is CnH2n plus 2 and और एक है आपका alkene है, इसका one double bond कम से कम एक double bond होना चाहिए उसमें, and it is given as CnH2n का molecular formula, इसका structure excuse me, इसका structure. And alkynes, it is going to be 2 pi bonds, in that a triple bond can be seen, and it is going to be CnH2n minus 2. These are all basic version of the hydrocarbons, and we are going to show all the detailed version of the hydrocarbons. And in this, various uses of hydrocarbons are there. Yes, hydrocarbons are generally useful as a fuel, and carbon 1 to 4 are gases, carbon 5 to 7 are low boiling liquids, and carbon 6 to 8 are liquids, and 20 24 also liquids, and up to after that you are going to get the solids and all. You can see heating of fuels and gasoline and jet fuels and the probable stove fuels, and everything can be seen there. And aliphatic hydrocarbons, what do you understand by the aliphatic hydrocarbons? Somebody please comment on the chat box. Yes, those students, there is a okay, Annamani is there today, right? And what about the other students? Yeah, let us talk about aliphatic hydrocarbons. So you have hydrocarbons two categories, aliphatic and aromatic. Aliphatic means they do not have the aromatic properties, and they are having maybe a saturated or unsaturated. They can be an alkane saturated, and alkene and alkyne are going to be unsaturated, and in that they have the boiling points and melting points increases as the molecular weight is going to be increased. You just see the best trick I can say, let it be for hydrocarbons means it is alkane and alkene or alkyne for any kind of organic species. You can say boiling point is directly proportional to molecular weight. How do you say it is a molecular weight? Is directly proportional to number of carbon atoms. Good afternoon here, number of carbon atoms. Yes, molecular mass is constant for its isomer. It is going to be boiling point is inversely proportional to, you can say it is a branching. So for a given isomeric species, good afternoon, I am fine, thank you. Let us conquer here and they are non-polar molecule and they have no polarity as well, are a knowledge king, boiling point. Abhinav, how are you? And maintain attractive forces or dispersion forces. They have London. Dispersion forces are the forces that operate in the hydrocarbons and less dense than water. That is about the alkanes. That's the reason why alkanes float, hydrocarbon float on the water. This is a very important point. And every line we are going to discuss in the NCERT based in this session. And of course, they are not soluble because they are hydrophobic. Okay. So why alkanes float on the water? Abhinav, you tell me why alkanes float on the water? Because their density increases as the molecular mass increases, but the density reaches its maximum to 1. So less than alkanes, density is always less than 1, it never be equal to 1. So therefore any alkane float on the water. That's good. And Abhinav, let us talk about saturated hydrocarbons. Saturated hydrocarbons contain carbon to carbon bond, single bond, and also it is saturated with hydrogens. Carbon iska 4 bonds are saturated and they are called alkanes. Chain alkanes have the general formula CnH2n plus 2, and the ring alkanes have the carbon to carbon single bonds, but their degree of unsaturation is 1. For cycloalkanes, the molecular formula is equal to alkene general formula. So cycloalkanes, however, they are saturated, said to have alkene general formula because it is cyclic structure. And also say classification of carbon bonds, you have primary carbon atoms, secondary carbon atoms, tertiary carbon atoms, quaternary carbon atoms. Carbon attached to one neighboring carbon is called the primary carbon. Carbon attached to 2 neighboring carbons, it is called secondary carbon. Carbon attached to 3 neighboring carbon, tertiary carbon. और आप क्या बोल सकते हैं कमेंट बॉक्स में देना, कार्बन ऑफ द मीथेन का नाम क्या? ये जो मीथेन है, ये मीथेन के कार्बन का नाम क्या? अभिनव, मीथेन के कार्बन का नाम क्या? It is called supercarbon. Methane, carbon in the methane is said to be supercarbon. And methane is said to be the parent of all hydrocarbons. And also say the number of carbon neighboring that, it is a primary carbon. ये जो carbon है, ये primary carbon बोलना है यार बेटा. And this is the carbon attached to 2 neighboring carbons, so that is called as secondary carbon. This is the carbon attached to 3 neighboring carbons, that is a tertiary carbon. This is the carbon that is attached to the 4 neighboring carbon, that is called quaternary carbon. Right? And let us see the types of hydrogens. The types of hydrogens. So the type of hydrogen is based on the hydrogen that is attached to that particular carbon is called, yes, that is called a primary hydrogen हो सकते हैं, secondary hydrogen हो सकते हैं, tertiary hydrogen हो सकते हैं. Okay, don't have a quaternary hydrogens. Okay, because carbon is already, it is saturated. Now physical and properties and melting points and boiling points, just we discussed. As you just see the melting point and the boiling point, of course the boiling point increases as molecular mass increases, whereas you talk about the melting points, it's very important, it is there in the NCERT. When you talk about the melting points, you are going to get zigzag kind of things, and carbon atom number 1, carbon atom number 2, carbon atom 3, 4, 5, 6, 7. So you are going to get odd number carbon atoms will have relatively low melting point than even number of carbon atoms. Okay. So it is subsequent even number of carbon atoms. So that's very, very important. SART pattern is seen and they have the very close values. And of course, when you talk about the boiling point values, the boiling point of the alkanes is too close. That's the reason why alkanes difficult to separate by distillation process. So for that, lot of expenditure is made in the petrochemicals. है ना बेटा? And the based on the melting point and boiling point, you are going to see the NCERT. Very good explanation is given here in this live session. My dear students, please like and share and subscribe these sessions with your friends, and please subscribe in this bell button, it is given. Okay, and Abhinav, how are you beta? Great. And आगे बढ़ते हैं. Solubility, of course, alkanes do not, hydrocarbons are insoluble in water, and but they are soluble in organic solvents. Of course, hydrocarbons themselves are solvents, right? And alkanes are the simplest family of the hydrocarbons, and they have a little biological importance also, and they are colorless and odorless. They are used in the paraffin waxes, they are used in the petrochemicals, fuels, and many more. They are used as a solvent, right? Okay. And also you can see chemical reactivity of alkanes. Alkanes being completely saturated, they are almost unreactive in the reactions. When they have complete saturation, they are not reactive, they are said to be paraffins. They are said to be paraffins. Of course, they can undergo the oxidation reactions or combustion reactions. In drastic conditions, they can undergo substitution reactions as well. When you talk about alkane, you add alkali, nothing happens. You add acid, nothing happens. If you add potassium permanganate in the dilute solutions, nothing can happen. So, very, very important, as the carbon atom is completely saturated, the alkanes do not react generally in any kind of reactions. Therefore, they are said to be paraffins. Then what type of reactions they can have? So they can have kind of substitution type of reaction, because there is no need of addition. Carbon tetravalence is completely saturated. So their saturation, you can't overcome the saturation, so that, and they are going to be substituted. One of the hydrogen from the alkane is going to be substituted to get its substituted product. Okay, you can also go for cracking. They can have halogenation reactions, they have combustion reactions, and there's a three basic reactions I just want to give. And from the NCERT line by line, I just want to say halogenation reaction is very, very, very important, and the mechanism is also important. Kapilendra, hi Kapilendra, how are you? You want to say something? Alami Salvayan. So, good afternoon. You please follow the lesson. Hi, you want to type something? Okay, let us go ahead. And alkane reactions, substitution reaction. Replace one hydrogen of the alkane with halogen atom. It is, yeah, Kapilendra Pangi, good, just, okay. Initiated by addition of energy to the form of the heat or ultraviolet light. That is important. Initiation is required. I am going to show you the mechanism. To start the breaking the bonds, generally get multiple products with multiple substitutions, right? So methane plus chlorine gives us chloromethane. You just say methane, chlorine is reacted in the presence of light. You are going to get methyl chloride or chloromethane. The side product is going to be HCl. Now ethane is going to give rise to ethyl chloride and HCl. Okay. So in that I have a different strategy to say this. Let us talk about the halogen. CH4, when it is reacted with halogen, one hydrogen is replaced with this, so CH3X, CH3X and HX, right? What is X over here? Kapilendra, it is going to be halogen. So X2 reactivity is going to be reactivity. Fluorine is more reactive than chlorine, is more reactive than bromine, is more reactive than iodine. So why fluorine is more reactive? Let us take an example of that. It is clearly mentioned in the NCERT, my dear children. Okay, methane, it is reacted with the fluorine. Methane is reacted with chlorine. Methane is reacted with bromine. And methane is reacted with iodine. So what kind of reactions? Yes, of course. And I am going to tell you what you want to say. Let me solve. Okay, please focus on the class. Now let us see here, going to get methyl fluoride and HF. You know this reaction is explosive even in the dark. When you talk about this, is going to give rise CH3Cl plus HCl, and in the dark the reaction do not take place, slowly, and in the presence of light it is going to be explosive in the light. So these live classes gives each and every point that is going to be discussed from the NCERT line by line. Okay? Now you are going to say methyl bromide and HBr. Okay, it is a moderate reaction. It is going to be a moderate reaction. In this moderate reaction, you need ultraviolet light. You need ultraviolet light along with some kind of heating is required. Okay. Now this you are going to get CH3I plus HI. Do you feel this reaction is very slow and it is going to be reversible? So that this reversible reaction, ये रिएक्शन आगे बढ़ने के लिए थोड़ा सा ऑक्सीडाइजिंग एजेंट इस्तेमाल किया जाएगा. HNO3 is an oxidizing agent. So you can see the reaction pattern from the NCERT also. You can see fluorine is extremely reactive than chlorine, than bromine, than iodine. Understand? Clear? Got it? Next. In this scenario, let us see the mechanism of the chlorination of methane. Any mechanism requires. This is a free radical mechanism, my dear children. Any free radical mechanism requires three major steps, that is initiation and propagation and termination. Let us talk about the initiation method. This is initiation, and it is a propagation, and it is termination. So let us discuss about what is initiation. In the presence of light, the chlorine is going to provide its free radicals. So the chlorine to chlorine, there is a single bond, a pair of electron is being shared, and this electron pair is going to be distributed by homolysis in the presence of light. It is going to give 2Cl dot, and this is a chlorine free radical is going to abstract one of the hydrogen from the methane, Cl, and it is going to be, this is abstracted, okay, and it will give you HCl and a methyl free radical, and this methyl free radical is going to attack on the chlorine. methyl free radical is going to attack the chlorine. So the pair of electron again undergo one homolysis, always gives a homolysis like this, so that it is going to give rise methyl chloride प्लस फिर भी एक क्लोरीन फ्री रेडिकल आपका वापस मिलेगा. एंड दिस इज हाउ द रिएक्शन इज गोइंग टू बी going ahead जब तक one of the reactant is completely consumed. So at the end of the show termination, ये termination में होता है क्या, initiation में energy देना है bond break करने के लिए, एंड टर्मिनेशन में जो आपका फ्री रेडिकल्स बचा हुआ ये जोड़ी करके आपका रिएक्शन खत्म होने का कोशिश करता है. सो उसमें CH3 एंड Cl डॉट गिव्स राइज CH3Cl, और एक चीज है Cl डॉट प्लस Cl डॉट गिव्स राइज CH, it is going to give you Cl2 and CH3 dot and CH3 dot, and it gives rise to C2H6 ethane. बच्चों यहाँ पर सरप्राइजिंगली ईथेन इज फॉर्म्ड, ये NCERT में आपका दिया. So whenever you study organic chemistry in such a way that you need to identify what exactly is happening, which of the following reaction happens or which of the following reaction do not happens during the chlorination of methane. So you have to stick on to the NCERT and identify each and every reaction and you just follow. Ethane is surprisingly formed, है कि ना? Right, very good. Any doubt, Abhinav? Lamisal Bayan? Any doubt? Anamani, any doubt? Okay, you please comment in the chat box अगर आपको कुछ doubt है ना तो, and in the chat box you have been given a link that it is a boost your NEET score with Infinity Learn, and click it on and you are going to get a exciting courses over there and you can enroll based on their course curriculum and everything, and grab your medical seat and it's all yours, right? Get ready, just a minute. So आगे बढ़ते हैं, moving forward we are going to see introduction of alkenes. Introduction of alkenes, you have the structure and bonding, it is having CnH2n plus 2, you are going to have complete minimum one carbon to carbon double bond. In the hybridization of alkene, carbon undergo sp2 hybridization. The carbon to carbon sp2 hybridization means whenever the double bond comes, it is going to have the sp2 and it is going to be planar trigonal geometry. And the most important point of the alkenes, one, you are good at alkenes, you can do the best, and it is all about the preparation of alkenes. First one is dehydration of alcohols. What is the meaning of dehydration? Removal of water molecule is called as dehydration. This is your alcohol. Alcohol contain OH group, that is what you call it as the alpha carbon. The carbon which bears the OH group is alpha carbon, and इसका बाजू में और next carbon is called as a beta carbon. So this is your leaving group, and the hydrogen from its beta carbon both are removed as a water molecule, and this is what you call as the beta elimination reaction. जहाँ पर आपका अल्कोहलिक ग्रुप एंड हाइड्रोजन निकला हुआ, वो दोनों का बीच में एक डबल बॉन्ड लगा दिया, सो इट इज गोइंग टू बी एन alkene, and it is followed by, it is mediated by an acid catalyzed dehydration of alcohol. And The ease of dehydration of alcohol. Tertiary alcohols are more easily dehydrated than secondary than primary because they form the carbocation. So let us discuss about the mechanism of the dehydration. You can use various kinds of ingredients as a catalyst. It could be acid catalyzed hydration. For that, concentrated H2SO4 is used at 170 degrees centigrade, and you can use H3PO4 at 380 degrees centigrade or 470 degrees centigrade. You can also use Al2O3 at 380 degrees centigrade, and heating with P2O5 or P4O10, and heating with POCl3 is also. There are so many kinds of dehydrating agents. 1, 2, 3, 4, 5 and 6 types of dehydrating agents are required. It's very, very important. And heating with POCl3 in the presence of pyridine, heating with KHSO4 is also very important. KHSO4 is an acidic salt, and this acidic salt can undergo dehydration. So, stability order of the alkenes. So, when you talk about the stability order of the alkenes, stability of alkenes is directly proportional to hyperconjugation. Stability is directly proportional to, dear students, hyperconjugation. Hyperconjugation. What is hyperconjugation? That is sigma pi conjugation, no bond resonance or Baker-Nathan effect. Dear students, in this, wherever the alpha hydrogens are more for alkene, that can undergo more hyperconjugation. So, more is the hyperconjugation structures, more is the stability. So, based on that, you can say here more substituted alkene is going to be more stable. That I can generalize that. So, that 4 alkyl groups are there. मान लो हर alkyl group methyl group होगा, so that here just 3 methyl groups are there and 2 methyl groups are there. So as the number of alpha hydrogens increases, the stability is going to be increased. That also can be explained on the basis of heat of hydrogenation. I can give you the values of the heat of hydrogenation and can tell you. And also transalkene is more stable than cisalkene, क्योंकि transalkene में 2 alkyl groups are in the opposite way, and the cisalkene में 2 alkyl groups are on the same side. They will be having a kind of repulsion. And what about this? This is what you call it as, मान लो R value is ये methyl group, and अगर ये methyl group होने तो इसका नाम क्या? Isobutylene. That is what you call it as isobutylene. Isobutylene is more stable than transbutylene. If anybody has an answer, why so? Please comment in the chat box. Isobutylene is more stable than transbutylene because isobutylene is stabilized by hyperconjugation. This hyperconjugation is giving the most stablest hyperconjugation structure. Therefore, isobutylene is, of course, it is more stable. Based on that NCERT, you are going to get a very good question. You can see here, and also you can see mechanism of dehydration of alcohol. I just want to discuss in a clean slide. Let us talk about CH3 and CH2 and OH. The lone pair of electrons present on the alcoholic group act as a Lewis base, and it is going to be donated. So, alcoholic group is a poor leaving group. When it is a protonated, it is going to have protonated alcohol CH3 and CH2 and OH2 plus. So, this is your protonated alcohol. This protonated alcohol is going to be losing its water molecule to give us its corresponding carbocation, so that it is corresponding carbocation gives us CH3 and CH2 plus. Formation of a carbocation is a rate determining step, and it is going to be the slowest step, and this carbocation loses its proton, and it is the first step. In this first step, H plus is lost, so you are going to get CH2 double bond CH2. So whenever carbocation is formed, it is going to give it some more stable rearranged product if some chance is there. Understand? Let us see the rearranged system. You can say if it is H plus and heated, you are going to get a alkene like this. So whenever you start something, you do the things in such a way that you should get maximum effort in that. And if you get a question based on that vicinity, you shouldn't dare to leave that. That is supposed to be done. Whenever this is, the water molecule is eliminated and OH is here. अब कैसा करना, हर चीज का मैकेनिज्म डाल के देखना, जहां पर आपका कार्बोकैटायन आना है, लेस स्टेबल कार्बोकैटायन rearranges to gives rise more stable carbocation, है ना बेटा? And this is a protonated alcohol. This is a protonated OH group is going to be more better leaving group than this, and you are going to see secondary carbocation. Secondary carbocation is going to be less stable. Therefore, this methyl group यहाँ से निकाल के यहाँ पर जोड़ी करना है, so that you are going to see the formation of ये tertiary carbocation का है. So tertiary carbocation is more stable किससे? Secondary carbocation से. So that energy profile, that secondary carbocation is high, energy of the tertiary carbocation is going to be less. So you can apply chemical kinetics और reactivation energy का जो graphs भी है यहाँ पे आप इस्तेमाल कर सकते हैं. And whenever it loses one proton ना, you are going to get its corresponding, it is going to get its corresponding alkene like that. Its corresponding alkene is like this. So the more stable alkene is going to be generated, right? Any doubt in that? Okay, very good. Let us do some more things over here. Dehydrohalogenation also follows the same way, and in this scenario you have to follow the Sergev rule that I am going to tell you. And yeah, arrange the following alcohols in the decreasing order of their ease of dehydration of H2SO4. Who is going to give the answer for this particular question? Make it fast. So chat box में फटाफट आपका आंसर देना भाई. My dear children, whenever you learn something now, you just identify how the question can come and you have to trick it. Okay, right. So ease of carbocation, ease of dehydration, जो भी reaction है, ये reactant intermediate दे देते हैं, intermediate product देना है. जो भी reaction है, ये reactant gives rise the intermediate. जिस intermediate में ज़्यादा stability हो, वो reaction अच्छा तरफ दे सकते हैं. So that I just want to say here, the ease of dehydration is directly proportional to the stability of carbocation. Ease of dehydration of alcohols is directly proportional to stability of carbocation, है ना? Stability of carbocation. In this you just say this is a secondary carbocation, this is a tertiary carbocation, and is also going to give it's a tertiary carbocation, and it is going to give the primary carbocation. Here going to give the secondary carbocation, but where this stability is more, that's what I want to say here. The carbocations are going to be given stability by virtue of either resonance or hyperconjugation, so that I can say यहाँ पर और यहाँ पर is going to be more stable, and it could be in the order wise or it could be in the single option type in the NEET examination. And this kind of discussions are important. Hare NCERT line by line you have to study, and the teacher has to teach for the NEET students who are preparing here, and you have to just focus how the question can be asked from that particular NCERT based. Understand? Okay. Now RX is here beta, rearrangement and Rinder expansions already we discussed. Okay. And yes, preparation of alkenes by partial reduction of alkynes. Yes, you can prepare alkenes by partial reduction. So whenever you just add hydrogen to alkyne, that catalytic hydrogenation is going to be such a fast reaction, you can't stop it, so that you are going to end up the reaction at alkane level. But I just want to stop the reaction at alkene level. For that I can go with, I can use a Lindlar's catalyst, or also I can go with sodium and liquid ammonia. I just want to discuss that kind of things here. You can see RC triple bond CR dash, this is your alkyne. So this alkyne can be treated with sodium or lithium in the presence of liquid ammonia. This is what you call it as a Birch reduction. I am fine, thank you. Mariam Dua, I am fine, thank you. Where did you go? Not seen nowadays. Whenever it is treated with palladium in barium sulfate or quinoline or calcium carbonate, I am fine, thank you Mariam. You are going to see R C double bond CR dash, and it is going to be transalkene, and it is going to give you, you need to have a quinoline as a solvent. Quinoline as a solvent, you are going to get RC double bond C R dash, it is going to be a cisalkene. Okay, this is going to be a cisalkene. So either transalkene and cisalkene, you are going to, these reactions are stereospecific, and this alkyne will be given. You are going to ask what is A and what is B, and this equation is very, very important. It is given in the NCERT textbook, and you follow these reactions, and this is a related content. Any doubt? Mariam, how are you? And in the description box it is given, boost your NEET score with Infinity Land. Dear children, you please focus and click on this link, and you can just go through various courses that are available with Infinity Land. You can have an awesome journey with NEET preparation with Infinity Land. It is AI driven program, is first time it is involved in India. Right, let us go and continue with the dehydrohalogenation, preparation of alkene by, why Arpit Pandey, why you are late? I just want to ask why you are late, beta. Good afternoon, good afternoon. How are you? Okay, alkyl halides undergo dehydrohalogenation when they are heated with a strong alkali on the base. So what is the base? Base is a substance which abstracts the H plus from a substance, from a molecule. Yeah, Arpit Pandey, I am going to discuss about dehydrohalogenation. So what is the meaning of dehydrohalogenation? D means removal, hydrogen, halogen. So removal of hydrogen and halogen is called as dehydrohalogenation, right? So this is the halogen, and the carbon bearing halogen is called as alpha carbon, and the carbon bearing adjacent to the alpha carbon is called a beta carbon, and the halogen is removed from the alpha carbon and the hydrogen is removed from the beta carbon. One halogen and a hydrogen are removed. So whenever a halogen and a hydrogen are removed, there is a double bond. This bond comes over here and this bond is going to leave from here, so that you are going to get an alkene. This reaction, what do you call it as dehydrohalogenation? It is a kind of beta elimination reaction. In this you can say alpha carbon से एक हाइड्रोजन निकालना है and हाइड्रोजन या बीटा कार्बन से निकालना है आइडो ईथेन और ethyl iodide when it is treated with potassium hydroxide. When you heat it, yes, this is an elimination reaction. For elimination reaction it is required to heat. Always ख्याल में रखो ये चीज, elimination requires heating process. Now I want to say this iodine and this hydrogen are eliminated, so that you are going to get ethene, and this ethene and the formation of Ki and water. And also you can see it is a oxide, sodium tertiary butoxide and butyl alcohol, ethyl alcohol and sodium methoxide, kind of various bases can be used. Okay, and that basis you can see the process of removal of molecule of hydrogen and halogen from a molecule is called as dehydrohalogenation. In the dehydrohalogenation it is a beta elimination process, and in the beta elimination process you are going to eliminate an hydrogen from the beta carbon, therefore it is a beta elimination process. Okay, your net is low. Follow the class beta. Okay, now in this the reactivity, alkyl iodide is more reactive than alkyl bromide, is more reactive than alkyl chloride, is more reactive than alkyl fluoride. Generally one thing, alkyl fluoride reactivity we don't consider, and also tertiary alkyl halides are more easily dehalogenated than secondary alkyl halide is more dehydrated than primary alkyl halide. Okay, and this kind of orders are very, very important from NCERT and NEET based preparation, my dear students. So you study your organic chemistry, or I teach your organic chemistry, or some other teacher teaches organic chemistry, guys, but how do you feel is doesn't matter, but how do you write your examination does matter, and this is the way you have to prepare it. Mariam, fine? When one chlorobutane undergo dehydrohalogenation, one hydrogen and one chlorine is eliminated, but-1-ene is formed. Okay, let us see one more chance. What could happen? Let us say an example over here. CH3, CH2, CHBr and CH3. When it is said that one KOH in the presence of alcohol, when it is heated, everybody knows this is a bromine, and one hydrogen is eliminated, so that you are going to see CH3, CH2, CH double bond CH2. This is the product. और एक possible भी है. Mariam, tell me, और एक possibility, it is a but-1-ene beta. And but-2-ene भी possible है. कैसे? but-2-ene भी possible है. एक chlorine, एक bromine over here and one hydrogen. ये भी बीटा कार्बन होगा ना, ये बीटा कार्बन से आपका मिलेगा, and you are going to see CH3 and CH double bond CH and CH3, and this is going to be but-2-ene, है ना, but-2-ene. ये दोनों में कौन सा मेजर होगा? कमेंट बॉक्स में, ओके, कमेंट बॉक्स में देना जल्दी, फटाफट, make it fast. This is going to be the major, my dear students. कैसे? So ये सेड जब रूल का हिसाब से ये मेजर होगा. क्या आपका सेड जब रूल क्या बोल रहे हैं? During elimination, the most substituted alkane is going to be the major product. So जहाँ पर एलिमिनेशन में बीटा हाइड्रोजन में कम नंबर बीटा कार्बन एटम पर कम नंबर ऑफ हाइड्रोजन है, वहाँ पर बीटा कार्बन एलिमिनेट किया जाएगा, so that the corresponding alkene is going to be the major. So during an elimination, the beta carbon which bears the least number of hydrogen is going to eliminate, and it forms the most stable alkene. That is what you call it as Said-Jeb rule or Jed-Jeb rule. Hope you understood this. Clear? Fine. And there is no rearrangement in this elimination reaction of this dehydrohalogenation process, and based on that you are going to get a very good question. And sometimes agar base is bulky, so आपका Hoffman product form होगा. So when the bulky base is given, potassium tertiary butoxide, okay, A वाला जो है सो आपका जो माइनर भी है मेजर भी है, एक चीज बताना चाहता हूं. सो इफ इट इज अ हाईली हिंडर्ड बेस, whenever the base is high bulky base or the leaving group is a poor leaving group, the product that is formed is going to be opposite to Said-Jeb rule. That is what you call it as a Hoffman elimination. Okay, in this Hoffman elimination you are going to see this is going to be the most substituted and it is going to be the least substituted. That least substituted is going to be the major whenever the base is going to be the bulky hindered base. अगर ये base hindered नहीं होगा, simple base होगा, this is going to be the major. So if the base is simple, Said-Jeb product is the major. If this base is bulky, it is going to be the less substituted Hoffman product hoga. This is what you call it as Hoffman product. Hoffman product. Understand? Clear? Mariam, any doubts? Arpit Pandey, fine beta. And और एक चीज देखना है, stereochemical requirement. Yeah, stereochemical requirement. So you are going to relieve a leaving group, that is your halogen and the beta hydrogen, and the beta hydrogen and the halogen and supposed to be in the opposite configuration. I am going to tell you that. Okay, so this is your beta hydrogen. Yes, this is your beta hydrogen. Okay, CH3 and CH3. So I just want to say this bromine and this hydrogen is going to be anti in configuration, so that the product is going to be like this. Could you tell me what is the product? अगर yes, it is there. NCERT में क्या simply E2 elimination by molecular is an anti-elimination. एक statement देके ये खत्म किया. But you have to know what is an anti-elimination. Yes बेटा, अर्पित पांडे, and this is the product. And मैं एक सवाल आपको पूछना चाहता हूँ, अगर ये प्रोडक्ट क्या होगा ये रिएक्शन में प्रोडक्ट क्या होगा? कमेंट बॉक्स में, चैट बॉक्स में आपका आंसर फटाफट डाल के देना, जल्दी, मेक इट फास्ट. we can do it. अरे बेटा ये अल्फा कार्बन होगा ना, ये बीटा कार्बन होगा ना, ये बीटा कार्बन में एंटी पोजीशन में मिथाइल ग्रुप है एंड हाइड्रोजन यहाँ पर ये कॉन्फ़िगरेशन में नहीं है, सो यहाँ पर आपका हाइड्रोजन निकाल के, डोंट लुक एट देयर, लुक एट हियर, सो इट इज गोइंग टू बी एलिमिनेटेड. As a result of this, you are going to see a multiple bond that is formed here. Bromine हटा देना and it is going to be like this. And it is going to be like this. Yes, hope you all understood this, right? Clear? Fine. And stereochemistry of elimination is very important. And also you can see, predict the order of reactivity of the following compounds. So I just want to know the answer for this. I just want to know the answer. Arpit Pandey, make it fast. Arpit Pandey, take time, everybody, focus here. So I am discussing the questions that are related to the NCERT based as well as your NEET examination based. And if the difficult and toughest of the toughest question asked from the NEET examination और जो भी कॉम्पिटिटिव एग्जामिनेशन ये डिहाइड्रोहैलोजिनेशन के हिसाब से इतना ऊपर क्यों देंगे, कौन देंगे, राइट? आंसर, मेक इट फास्ट. ओके, नाउ let us see, according to the elimination process, the product that is formed is going to be alkene. Yeah, we are in hydrocarbons now. In this alkene, so जो भी रिएक्शन है जहां पर ज्यादा स्टेबल प्रोडक्ट होगा वो रिएक्शन आसानी अच्छा करना है, सो दैट दिस डिहाइड्रोहैलोजिनेशन, इस रिएक्शन में आपका जो रिएक्शन है and you have to give it a corresponding alkene. So the stability of alkene देखना पड़ता है. alkene stability किसका ऊपर डिपेंड करते हैं? अभिनव, अर्पित पांडे, okay, Mariam Dua, and stability of alkene is based on the hyperconjugation. Okay, so based on that, let me give you the correct alkenes that are formed. I just want to write the alkenes that are there that can be formed here. It is going to be alkene, it is going to be the alkene, it is going to be the alkene, it is going to be the alkene, फिर भी ये, it is going to be the alkene. And when it is coming to the alkenes, the rate of dehydrohalogenation, alkyl iodide is more reactive than, alkyl iodide is more reactive than, alkyl bromide is more reactive than, alkyl chloride is more reactive than alkyl fluoride. So that alkyl bromide is more reactive than alkyl chloride, like that. So at the end of the reaction, everybody focus over here. You are going to see the correct order of reaction. 5 is more. Why 5 is more? Here I just want to use the bromine as a leaving group. Then 3. Why 3? Bromine is the more reactive. Then it is coming to the 2. Why? Because it is true chlorine, but it is going to form the isobutylene as a product. And 4, it is going to be, bromine is the reactive, and at last we are going to go and say that it is the iodine, chlorine is the least reactive. So in this scenario, you are going to see the order of dehydrohalogenation is asked. In this dehydrohalogenation, you have to see the stability of the alkene that is formed, And regarding the stability of the alkenes, you can arrange this order. And also bromides are there, chlorides are there. According to this reactivity of order, you can say alkyl iodide is more reactive than alkyl bromide is more reactive than chloride than fluoride. Whenever fluoride comes now, it just leave it, because the alkyl fluoride is going to be having a completely different version of the configurations and their reactive nature. That's the reason why I just want to give alkyl bromide is more reactive than alkyl chloride. Based on that, 4, 3, 2, 5, 3, 2, 1 is the correct answer here. 5 is greater than, 3 is greater than, 2 is greater than, 4 is greater than, 1 is the correct answer, right? So in today's class we discussed about the chemical reactions of alkanes from the NCERT line by line. I have given the mechanism of the chlorination of mechanism. Anemone is there, right? And we already seen the preparation of alkanes and alkenes here, dehydration of alcohols and dehydrogenation of alcohols, right? Hydrocarbons. And also in the next coming sessions we are going to see the chemical reactions, electrophilic substitution, electrophilic addition reactions, and in the various forms in the reverse direction of the hydrocarbons and ozonolysis and oxidation reactions, and many more are there. Okay, hope you like this today's session, and please like, share and subscribe with your friends, and please press the bell button so that you are going to get all these links and updates for NEET examination preparation. Attend your daily sessions with your Infinity Learn NEET channel, so that you will be getting all the new stuff with various NCERT based stuff. Are you getting or not? Yes. You like it? Mariam Dua, Arpit Pandey, okay, Lami Salvian and Vanga Annamani. Okay, thank you very much for the session, and hope you enjoyed. Please like the session and share with your friends, and subscribe to Infinity NEET channel. Thank you. Signing off, Suresh, Faculty of Chemistry from Infinity Learn. Thank you. Bye-bye.